Hello, welcome to our panel discussion, AI Goes from Disruptive to Imperative, Publishers Overcoming Hangups and Getting Real with Intelligent Automation. I am the moderator, Erin Cox. I'm the U.S. publicist for the Frankfurter Buchmesse. And on our panel today, we have Mike Groth, who is the Director of Marketing for Synveo Publisher Services, Josh Nicholson, CEO or co-founder and CEO of Site AI, and Niels Peter Thomas, who is the Managing Director of Books for Springer Nature. Artificial intelligence, or AI, as we talk about it, is everywhere. We as people use it every day, from the predictive text in our email to chatbots that help us troubleshoot or purchase things online. Today, AI is now being heavily utilized in industries such as automotive, manufacturing, finance, healthcare, which we've seen a lot of growth in during the COVID pandemic, and even retail. According to a report by Grandview Research, the global AI market, which is currently valued at $39.9 billion, is predicted to grow 42% year over year from now until 2027, reaching a value of $733 billion. Last fall, and yet actually in academic publishing, AI is still in early stages of implementation. So last fall, Unsilo conducted a survey of academic publishers on their current and expected use of AI. Over 2/3 of publishers are using at least one AI tool, though a portion of those respondents weren't entirely sure what the tool was used for. 45% of publishers not currently using AI tools plan to introduce them in the coming 12 months. And those who are not using AI tools cite a variety of reasons for not using them, including not enough AI trained staff, not sure of the benefits of AI, and the cost of implementing these systems and tools. AI is currently being used primarily to enhance staff efficiency, not create new functionality. What we were talking about today is why academic publishing must embrace AI now, not as a possibility for change, but as a necessity. So I'm going to turn it over to Mike Groth, who will talk a little bit more about that.
Great, thanks, Erin. My name is Mike Groth. I'm the Director of Marketing at Synveo Publisher Services, and Synveo has been working on an AI tool over the past few years to help speed up the publication process. So I'm really excited to talk about that. I personally have worked for Synveo for about 2 years, but I've spent 25 years in scholarly publishing, all of it on the marketing side, and both from a publisher and a vendor perspective, so I can appreciate both sides. So I'm going to give you just a little bit of background about Synveo. Many people with SSP will be familiar with us. We are an editorial and production solutions provider. We offer end-to-end workflow optimization solutions from the acceptance phase to the publication phase. We worked in journals for decades, but also in books and other digital media. We're based in the US, we have a presence in the UK, but several large facilities in India. And our claim to fame in the AI space is our automated production engine, which is called SmartSuite. So just taking a step back for definitions just for a moment. So what are we even talking about when we say AI in publishing? So most people recognize that it is the simulation of human intelligence by machines. But there are other terms. You'll hear me say NLP, or natural language processing, a fair bit. And what is that? It's really just AI, applying the AI in order to add value to human language. And our requirements in order to use AI in a publishing system is that it needs to be a self-learning system that acquires rules and uses reason based on these rules to come up with a prediction and then execute and make changes for a result that is many reduced errors and increased speed in these processes. So this is my quick, probably oversimplified sketch of the various phases in the publishing process. The different speakers will cover components in different areas. They cover AI applications are used pre-submission to post-publication, and everything from peer review these days to the various steps in the publication production processes, and then post-publication in product development and discovery. So the Synveo component covers the middle, copy editing, composition, and conversion. I'm mostly going to focus on the language quality analysis of our copy editing solution. So again, take a step back. What are we trying to accomplish? It's not just a story of how do we apply AI in publishing. It's what are we trying to do? And for us, it's about reducing time to publication as much as possible by automating workflows with the ability to actually improve editorial quality at the same time, because our system is largely a rules-based system, and machines are much more efficient at applying rules at scale consistently than humans ever could be. And there are actually two really important outcomes from this. One is to enhance the author experience. We know from talking to our customers that speed to publication is a top priority for their authors that come back in their own author satisfaction surveys that they conduct. And I can attest from my experience working from Emerald, we did an annual global author satisfaction survey. And again, that was always a top priority. But it's not just about advancing the career goals of our authors. Publishers, of course, that is, authors are one of their most important constituencies, but there's another outcome. This is about really boosting the immediacy of science, which I think has never been more true, demonstrated to be more the case than recently during the surge of really critical coronavirus research. Symbeo, the customers that we serve, have definitely experienced this surge in critical publications, and we've used our systems to help prioritize and fast track articles, and we've even published a blog post about that experience. So I'll give a quick case study so that you become a little bit more familiar with how this actually works and you know what I'm talking about. So it's easiest to tell the story of a particular publisher. Taylor & Francis is a customer of ours that was the first to really embrace the full features of our Smart Suite platform. And what they were looking to do was speed up the production process by tracking editorial intervention by humans versus machines based on language quality. So TNF used Smart Edit to create 3 streams for production. There was a no edit stream where manuscripts were of sufficient quality that they could pass right through the copy editing phase straight to composition without human intervention, except for maybe making a couple of stylistic and formatting edits. A guided edit stream where the NLP scored anomalies and mistakes and created a report that assigned it to a human copy editor to make the final determination of these changes that were suggested. And then a full edit, say perhaps an author's first language was not English. So it doesn't mean that the article is of poorer quality. It just means that it needs more copy editing intervention. And so those manuscripts would be kicked out of the system and assigned for a full edit. And the result for TNF was that copy editing was no longer a bottleneck in their process. It was previously one of the most time consuming. And proofs could be generated to authors in as little as 24 hours. And it resulted in up to a 40% savings in overall production time, with a full quarter of submissions being able to advance straight through the system to the composition phase. So this is what Smart Suite looks like, just so that you're a bit more familiar with the technology. So we have a tracking dashboard, the copy editing and language analysis application, an automated composition module, and then a self-service author proofing interface. And AI enters into the system in various different places to improve the editorial and data quality, such as recommending changes during the author proofing stage, or tracking and outputting structured XML in the background. But it's really about the language processing that I want to focus on. So just zooming in on that, this is a screenshot of an error report that the system would generate for a copy editor based on a guided edit stream. The NLP analyzes the language quality. It recognizes sentence structure, subject, noun, verb, preposition, and using a rules-based system analyzes the grammar and style, perhaps UK versus US usage. Symbeo has created a dictionary of some 800 terms in variations of British and American English that are important for our transatlantic publishers. These rules can be based on just English standards or publisher-specific or even journal-specific rules. An example of something that the technology would look for, say, is funder information. Some publishers require, or journals require, that citations to funders are formatted in a certain way, and the NLP can look for, identify, and format the data accordingly. So the system will make corrections or flag them from editorial review, and this is the weighted scoring metric that a copy editor would see in order to make the final determination. And this is my last slide. So just where do we go from here? Now that we have a critical mass of journals and publishers and subject areas running through our system, when editorial intervention is required from a human copy editor, the system tracks all of these actions and learns what the human judgments are making. So these are output as rules that over time can be aggregated to use and make predictions based on this human behavior. And so when these commonalities across human interactions are applied with preset robust rule sets, the result is really high quality and high speed automation without a trade-off in editorial quality or an increase in headcount or anything like that. So this is where we're going next. So that is my part, and I think now I turn it back to Erin.
Yes, and we'll turn it over to Josh to talk a little bit about what Cite is doing.
Great. Yeah. Awesome. So yeah, thanks for having me on this panel. It's interesting to talk about AI because I don't have necessarily a background in it, which I think is, you know, something of a strength and obviously also a weakness. And so here's my contact information. If you have any questions or feedback as you're watching this, you can reach me directly at josh@cite.ai or our Twitter handle, which is @cite. And so I like to kind of start these talks on a positive note, especially in today's, you know, world, to remind us all that, you know, what we're doing, you know, with publishing, AI, and editing is really, you know, trying to help encourage some of the most amazing stuff, you know, that we've researched and created. And so I say that science is amazing. It's brought us the ability to have these virtual chats, hopefully, you know, life-saving vaccines coming soon, telescopes, and then the powerful computer that's in your purse or your pocket have all, you know, been a result of foundational scientific research. And while it's amazing, it's also inefficient. And so behind science are people. They're imperfect. There's a lot of, you know, incentives, not necessarily to do the right thing. And about 5 years ago, there were some results or studies looking at kind of the science of science. And so that is, if we take a scientific finding, can we validate it so that we can build on top of it with new findings or new products or new ideas? And so that is our aim at Cite, is to you know, continue to kind of help science be amazing and to make sure that scientists, the public, everyone can more reliably understand it and use it. And so the way that I like to kind of show Cite is to show the world as it exists without Cite, and then to show the world as it exists with Cite. And so very, you know, generally, Cite is a tool that allows anyone to see how a scientific paper has been cited, and specifically if it's been supported or disputed. And so I like to show my own research. So I have a background in cell biology. This is actually my research, which was published in eLife. I did my PhD at Virginia Tech. We collaborated with the hospital in Portugal, as well as a lab at the NIH. It's been cited 40 times and then viewed roughly, actually that's about 6,000 times now. And so this, you know, number, or these numbers are really primarily used as a number. And so if you click through, you might see a list of titles, but you can't really easily tell what are all these different articles saying about, you know, my research. Are some of them supporting it? Are some of them disputing it? How are they mentioning it? And so with Cite, we use machine learning to extract out the text around a scientific citation, and then we classify it using a deep learning model to say that they're indicating support or that they're disputing it. And so in this example of a supporting citation statement, you can see how it's classified as such. So it says in agreement with previous work, and then there's the citation to me. The trisomic clone showed similar aberrations, albeit to a lesser extent, supplemental figure S to B. And so next to it, we show, the deep learning models that show, okay, it's 93% confident that this is actually supporting. And I think, the way that we've set up Scite gets to kind of one of these points that you initially touched upon, Aaron, which is trust, right? How can we trust what this intelligent system is doing? And so by allowing people to see the context, is it actually supporting? Can you see why it's supporting? And then here's what the model has said, helps build trust. And I think that's something that's very important for us as a company, because it wouldn't be sufficient to say this is supporting or disputing, just trust us without being able to see it. Next to the classification, we also have a flag. And this flag, allows people to say, hey, your system got it wrong. It should actually be supporting. They can give the rationale, and then that's either accepted or rejected by two independent experts. And so how do we do this? Well, as I alluded to and mentioned very briefly, we use a lot of fancy techniques, so a lot of machine learning as well as deep learning. There's really kind of two parts of the process. The machine learning goes into extracting information out of scientific articles. So most articles still are in PDF if you go back, pre-2000. And so we use a lot of machine learning to extract them out, and the background kind of shows what this looks like. That takes into account 20 to 30 different features for each model. Once we have the in-text citation, we then have a deep learning model that's been trained on 45,000 manually annotated citation statements. And so I give this part of the talk, generally to kind of wow people and say, wow, there's so much machine learning, there's, all these different features, there's deep learning. But I think they can also have, an unintended consequence of like, okay, what the heck does that mean, right? Can I trust this? What is machine learning and what is a feature? How this seems like magic going into kind of creating this. And so I think this is one thing that we as companies and products using AI kind of are on the edge about, right? We want to say, here's AI, we're artificially intelligent, but at the same time that causes, I think, some distrust with people. It's just like, okay, I don't really understand that, so I don't necessarily understand kind of the product from it. And so this is something that we've experienced, very recently, and I don't think it's true to just citations, but as of the 23rd, there was a post on the Bibliomagician talking about AI-based citation evaluation tools, good, bad, or ugly. And in this piece, there's definitely some nice words to be said about Scite, but there's a lot of kind of caution and warning. Is like, how can we trust this new artificial intelligence? Will it make things worse? So many question marks. And I think this, is seen by all these different lectures on, like the one we're giving, as well as different posts in science and video lectures as well. And so I think to kind of give some clarity into AI, it's useful to show, okay, how do we utilize it, right? How do we utilize it just like how do we utilize, software development? And so on the right, is showing how we annotate citation statements. And so essentially what we're doing as humans is reading these citation statements and understanding them as humans and saying, okay, this one says, however, the data based on one RS sequence information are markedly below the 92% rate published earlier by Flavel et al. And then there's a target citation. So you read this, you understand this, and then you make a determination. Is that contradicting? Is it mentioning? Is it supporting? Or is there some weird error? And so that's really kind of all it is, right? We're reading a bunch of things and then scoring that this should be this. And we're doing it amongst not just one person, but multiple individuals where there's ways to measure amongst individuals. Is there agreement? Are they agreeing more than often? If they're not agreeing, then that's maybe a much more difficult task and maybe can't be automated. And I think once you kind of see, under this curtain or behind the curtain, some of this magic goes away, and I think that helps build trust. Another way that I really like to kind of visualize this is, here's this tokenizer. So here's these words that are going up, they're being cut in. And if you do something so many times and add this training data, the frequency of different words or the frequency of different classifications will appear. And so that is, essentially how our model is working. It's looking at the sentence structure, what do the words mean, and then coming to a determination. It's never going to get it perfect, but I think it allows us to, do things that humans otherwise couldn't. And so Scite is a team of 5, very small, and to date, in a very short amount of time, we've analyzed hundreds of millions of citation statements, so 616 million. And that is really because we utilize, artificial intelligence or machine learning and deep learning. That comes from 18 million full journal articles. So trying to read that as humans is just, really a non-starter. And from these 18 million, there's, we have information on almost 37 million different articles that otherwise wouldn't exist before. And so again, the ability to kind of automatically process these things at rates of about 500,000 PDFs a day is just something that, really humans couldn't do. I mean, maybe it could if the entire world came together to do this, but I don't think that that's going to happen. And so I'd like to kind of finish that on this by alluding to, some thoughts that happened, not very recently, but back actually in 1964. And so this comes from a writing by Eugene Garfield, who created Web of Science. And I highlight this excerpt where he talks about an intelligent machine examining a new document and generating a critical statement such as rather poor paper or things like this. And so before that, he also discusses markers, and these markers, appearing alongside the traditional citation index could be a critique, or Mr. X is wrong, or calamity for mankind. So that is effectively what we're doing. And I would say the idea for what CITE is doing has existed, since 1964, and many people have tried it before us, but they haven't been able to because the technology, really the deep learning models weren't there. And I think that is an exciting thing that we can take from, all these advances that we have in artificial intelligence and machine learning, is that it's solving problems that have existed that otherwise couldn't be solved before. And so we're not just using AI to use AI. We're really using it for this purpose of trying to improve, how the research is understood, evaluated, and ultimately, used. And so again, if you have any questions, feel free to email me directly or tweet at us, or any other way. And so thanks again, and looking forward to the discussion.
Thank you, Josh. And now we're going to turn over to Niels, who will talk a little bit about what Springer Nature is doing and Beta Writer. Niels?
Yeah, here we are. So thank you very much, Erin, for having me. And I'm happy to talk about a project from Springer Nature. It was a major milestone for us that in last spring, early in 2019, we published a book that from the outside, you see it here now twice on the screen, looks really like a regular book, but in the inside, it's actually something new for us, because this was the first book that we published that does not have any author anymore, in the sense of that there was a human who would write that book. You see on the cover that we still have a name on it. We call the creator of the book Beta Writer, and it should be indicating that this is still for us a project in beta test. So we are still improving it, and we're still working in refining the algorithms behind. But that's actually the first academic, in a way, meaningful book written by an algorithm, written by AI. And what it does so far is, or this first attempt that we tried, we did a few more since then, but this first one was on lithium-ion batteries. We could have picked any other topic. We definitely wanted to do something outside of the discipline of computer science. That was too obvious for us, so we wanted to have something from the sciences. Yeah, we tried 1.5 years to create this pipeline of algorithms to come up with this new book, and then realized it in April last year. So it is we call it a cross-corpora summarization of existing texts. So what the algorithm actually does is reading, in this particular case, I think it was more than 5,000 book chapters and journal articles on this subject discipline, then clustering the content, understanding what is important in this field currently, what is not important, what are the hot topics that real humans, real researchers are writing about when they are summarizing this field, and then finding patterns in it, and identifying important texts identifying those elements that are really necessary for a newcomer to this topic to understand what's going on in this discipline of, in this case, electrochemistry or lithium-ion batteries or accumulators. We did so, and it worked out, and we received actually quite a lot of media attention when we did so. And we were quite happy about that. Also, not only the tech journalists really jumped on it, but also the academic community said it was a meaningful exercise that we did. So we received lots of feedback from chemistry PhD students who said, this is an excellent opportunity for me to really digest everything that was published on this discipline in the last, let's say, 2 or 3 years in a very short summary. So it's kind of a bias-free summary of everything that is known about this topic, and that, of course, similar to the examples that Josh and Mike gave, was only possible with a machine and is not possible with a human anymore. So that's really the interesting part about. Now, the question is this really utopia for us? Is it really helping, or is it dystopia? Because we can just press a button and create a new book within a few minutes. That's also very tempting, of course, because we don't need any authors anymore. We don't need to pay royalties to our authors. We don't need any acquisitional editors anymore. If you can believe this is helping us as a publisher a lot. But then on the other hand, of course, it's not that easy and not that straightforward, because first of all, you could argue, is it actually really new knowledge in this book? Yes or no? Is it creative? Is it a creative act compiling this book? And I would actually say it's really something in between still, because of course you could argue everything that is in this book was already published, so it's just a summary, it's just a smart compilation of a lot of citations and a lot of interpretation between these citations. But then on the other hand, it gives a new perspective, because the clustering and the selection of what is important here and what is not important, what should be included in the book and what should not be included, is of course an act of this algorithm that was not created by a human author. So it adds a new perspective. It shows something that was not shown before from this selection. So this is why I think it's worth definitely experimenting with it. And since then, we've done a lot in these last 1.5 years with this technology. We improved it in many of the stages in between. But what I think is really worth mentioning, that since then we experimented also a lot with the degree of automation in our books. So I was just this example that I've shown, the lithium-ion battery example, is really 100% machine generated, and that was important for us, that we, at the beginning, when we show this technology to the communities, that we show what is possible right now, what is cutting edge research on creating this book in a humanly readable form. I'm not sure if our algorithms will be used only in the future for this purpose, because I see a lot of other applications actually where we are using only maybe 10% or 20 or 50% of machine created book within a kind of joint work between the machine and the author. And I see here a huge potential, not only for publishers, but also for science in itself. I mean, Josh, you said about making science efficient, and we believe actually that a lot of work that authors are doing when they create a book, when they write a book, isn't a very efficient process, not only because of the accuracy of the results, but also because if you want to write a monograph on a certain discipline, then you have to spend a lot of time in finding accurate citations for your introduction chapter. You're looking at the basics of the discipline to give the overview and so on. Maybe the time of a researcher who is really a specialist in a certain area should not be wasted by this really basic material work, finding a nice intro for this new topic. Maybe that should be done by algorithms if it's possible, because the researchers should then concentrate on the more creative part, the part that cannot be substituted by anything artificial, but can only be done by real intelligence, by real human researchers. So for us, the idea of creating these kind of books is also very much in helping authors, making it more efficient to write, not helping them making it more efficient to read, but to create this new manuscripts. And there are all kinds of parts of the algorithms that could really eventually help real authors and real researchers to be more efficient in their creation of a new manuscript. Which I guess brings us then to the conclusion that I think we are just at the very beginning of a change, but similar to what we have seen in industrial work, I guess the work of researchers might also change in the future, in the sense that they should really concentrate on the experiments, on creating knowledge, on really doing reproducible results, and not so much on looking for a nice way of putting things together or forging words and sentences so that they can really create something nice and something really meaningful, but with the least waste of time on things that can be created by automates, by algorithms. So I think eventually this technology or this idea that we started here will not only help the publishers but also the researchers, ideally, if we apply it in a responsible way. But I guess that's a topic that we should address a little bit later in the discussion.
Yeah.
Yep. Erin, over
Great.
to you again.
Okay, thank you, Niels. Thank you, all of you, for these great presentations, and I think that leads us to the question that we put at the heart of the title of this session, which is AI imperative to academic publishing? What is the industry missing out on if we don't begin to adapt this technology? You've given a lot of very great use cases, but we had sort of academic publishing prior to this. Are we missing out? Are we going to lose something by not embracing AI?
Yeah,
Niels,
I mean,
you want to start? Or Josh, go ahead.
I mean, so I think yes is the short answer. I think, and I think as you know, there's early adopters, we'll start to see what are people missing out on, right? So I think it's always important to look not at just like the method, but the benefit that we get from that method, right? And so more efficient workflows is maybe a quicker time from submission to publication, which is a big problem. Better suggestions, better ways to discover research, all of it can be powered by AI. And I think as certain publishers and journals start to adopt it, those journals will, naturally attract the people, and then slowly, people will follow. And so I think it's natural to have some wariness about new things, any new thing. And then especially because AI is such a broad umbrella term, right? It has totally different uses in all these different ways. And so I think it's important to kind of compartmentalize it for each different thing and say, okay, how is it being used in this case? Can I really trust it? Do I understand it? And then if so, to adopt it, because we use a lot of development things that we also don't understand, right? Going on behind the things, and so it's not, oh, I don't trust this software development thing. You see the use case out of it and clearly adopt it. And so I think I do think it's a matter of when, not if. And I think all these great examples, I would love to have Beta Writer be kind of a co-author on a piece, because there's a lot of work that goes into it, and a lot of it is very mundane, like formatting references and things like this. And so saving out on things like that will be great. And I think as they provide benefit, they'll be adopted as well.
Yeah. So speed to publication, efficiency of work, maybe better access to better research, or rather than just the research you can find. Those are some of the things. Mike, you look like you were going to start to say something.
Well, I mean, you won't be surprised to hear that I agree with Josh that it is imperative. I really believe that it's the way the industry is going, and the world in general, really. So we just heard a number of from high-level conceptual applications down to very practical applications. And publishers, this isn't just a fad. Sometimes in panels like this or at conferences, you'll hear a lot or read a lot of blogs about, say, blockchain, and it peaks and then sort of disappears into the background as a topic. Not that it really went away, but there are so many different tech companies and publishers experimenting in so many different parts of the process. And that I think that, publishers who, part of your question is what happens if publishers were to ignore it, they're really going to be left behind when their competitors are able to better meet their author satisfaction or publish faster or personalize the user experience in a better way or better understand their data. There's just so many ways that it can be applied.
So in terms of publishing buzzwords, AI is more like metadata, which we've now proven is vital to our business, whereas blockchain, we've not yet proven that. So AI is closer to the metadata of like, it's very useful and important.
Yeah. But Erin, also I would say that, I mean, if you only take these three examples that we've heard here in this panel, and there are many more that we could refer to, it's interesting to see that some applications simply create somehow a little bit better margin on the cost side, so that you can do something a little bit more efficient, which is, I think, if you scale it, already something really important. But then on the other hand, you have applications like what Josh explained. I think it's clear that it would not be possible at all with manual work. So you have really a different quality of data that you can achieve. And in some cases, you really have just better quality of data or metadata. Maybe it costs the same, but then the quality of the content is better. So you have all kinds of improvements, I think, in very different dimensions in a way from AI applications.
Definitely. Yeah. And I think that sort of taps to what Josh was saying, is that there are like different parts of the industry in which AI is being implemented, and it can, depending on your company or what you're doing, that can make a big difference in a lot of different ways. That sort of leads to my second question, which is, which areas of academic publishing, publishers, researchers, institutions, do you see the most growth in using AI, just in your partnerships and people that you're working with, or things that you're seeing?
I can maybe continue to start. So from my end, I think, publishers, where are their pain points, right? And what are the most monotonous things that they have to do, and what can be solved in there, right? And so Cite, works at the publication level, where it's helping readers. And that's not necessarily like editors are saying, oh, we need to show better citations because that's helping my day-to-day. It's really not. And so what we've heard from them is, hey, we deal with a lot of submissions. We don't know, what should we send out for review? What is good? What is bad? So there's a lot of manual work that goes into that. Is there any way that Cite could improve this, for example? And so we, actually developed this reference screen. So before things are published, to kind of check the references. And I think the reason we did that was born out of the demand. And so I think really kind of at the submission stage, and what Mike spoke about, during typesetting, all these things, there's massive amount of human labor going into that now. And a lot of this is very repetitive and boring work. And so if this can be automated, then people, are clamoring for it. And I think that is where most growth is happening currently. But I do think like the larger potential, goes from, okay, let's solve these efficiency tasks to what new can kind of come out of this. And so that, it's crazy to even think about beta writer as like your co-author on a paper and things like this. But really, like, hypothesis generating AI could be something that's, okay, maybe I'm not going to just follow this like a robot, or maybe that's not a good example, but here's an idea that I can go forward that's synthesized from all these things that I as a human otherwise couldn't comprehend. And I think all the things that we're addressing in these different talks, it's only going to become more of a problem or opportunity because the volume and the scale of things is continuing to increase. It's not getting less. Like, we're getting more and more publications each year. It's getting harder and harder to deal with all these different things, from understanding to publishing, so on and so forth.
Right. Yeah, I mean, I think that's something that we've seen in the last, I don't know, 10 or 15 years is just the vast amount of information. It's impossible to curate, it's impossible to discover. And so AI allows, you know, the ability to process so much more information than we possibly ever could as humans. So which both you and Niels have highlighted in your presentations. Does anybody else have any thoughts on growth and maybe in the practice and the people that you're relating to, Mike? Maybe, you know, your customers or anybody that you're relating to in your work.
Well, publishers, as Josh mentioned, publishers really have the infrastructure and the incentive to invest in this area. And there are solutions that are researcher facing, but oftentimes it requires publishers to open up their libraries for the bots to scan the corpus of literature in order to extract the concepts and develop the semantic relationships and everything. So I think publishers, again, would be missing a beat if they didn't take advantage of the opportunity to provide this as a service.
Yeah. So given all the benefits that we've just sort of highlighted, why do you think publishers, do you think trust, I mean, we've given sort of cost, trust, some other things. Do you think that is it mostly trust that's like stopping publishers from embracing this wholly, or is it that they haven't seen enough use cases? Or Niels, with your peers in the, you know, your competitors, is anybody developing sort of a beta writer for them or anything like that? Or are you seeing any of that kind of work?
Yeah, well, I mean, there are some trying to do something similar. I mean, if you're asking what are the reasons why adoption is relatively low, or what is the reason why not more publishers are really into it? I think, especially in academic publishing, I mean, it takes some courage to say that we are trusting a machine over our own stuff. Yeah, and I fully acknowledge that. I mean, I had really a lot of discussions internally and externally in also all kinds of also ethical and also technological discussions. Can we do that? What if it fails? What if there is a mistake in it? I mean, I also had lots of discussions with my legal department, actually, saying, what if the algorithm accidentally infringes the copyright of somebody? Yeah, well, who will go then to jail? It's me as the managing director. It's not the algorithm. Yeah. So yeah, you have to. It's really. I mean, I don't want to sound pathetic, but yeah, somebody has to drive it. Yeah, because it's also something that where you have to take risks. And after a while, I think you get familiar with it, and then we accept it. And I mean, it's the new thing that we have to deal with and say, okay, let's do this as a proper experiment. And I think, for me, to overcome this trust issue is so one thing I think is really about transparency. We need to speak about it. We need more panels like this really to build this and say, okay, now let's give it a try. And where we do it, we actually show quite good and interesting results. I mean, there are 10, maybe 20 other key activities that we are doing within our company where AI plays an important role in metadata creation, in auto-summarization, in auto-translation, be it customer-facing or be it completely internally. I mean, there are so many things that we are doing, and I guess we are probably relying on even more AI without knowing it, because it's somehow hidden in the processes of our vendors or of things that we buy and use. So I think we have to learn more about it and then really take it. Other than that, of course, it's also a cost issue. Yeah, if you develop it, it's in the short run, it's not the best idea. If you have a running system, why should you change something? But I think I guess that's the idea of every innovation. Yeah, you have to invest, and then you come up to a better situation. Hopefully, soon after it.
Right.
Yeah, but I guess it's really the obstacles are similar to many other really true innovational hindrances that you could have. Yeah.
Right, right. Yeah, and I think, I mean, one of the things that we've sort of talked about is sometimes, you know, the machines making mistakes and who catches that, and that's also a challenge that I think publishers have in thinking like, oh, humans will be better than a machine would be, but they're, you know, what can we do to sort of, I guess, maybe show more transparency or give more information to people of how the system actually works, that there's actually a person there who is catching those mistakes, or how do we sort of pull the curtain back on that a little bit more? Maybe Josh or Niels, if you want to take that.
Yeah, so I mean, I think there's kind of two things that I would say about this. One is like, is it actually solving a problem, right? Like, so is there a problem that this is solving that is clear to me? Then, you know, then there's trust with that. Okay, it solved this problem and it did it well, as I've done this so many other ways. And I think that's true of all things that, you know, are new, right? People create a lot of new technologies, new products, new companies, and some of these are nice to have, but a lot of them don't solve problems and then they go away. And so I think, you know, if it solves something, how it solves it becomes kind of less important. And again, like I always think of like AI is so new and so fancy, but so it's like software development. I would say most people using all, you know, different like Python and JavaScript, they don't understand all of that, right? And that's because they don't need to necessarily. And so I think that's one thing, is it clear how it's solving this problem? And if it is, then I don't need to understand every model because I understand kind of the outcome. With that said, I do think there's an opportunity to kind of, you know, reveal more detail. And so Cite, you know, is it's a good thing, is like people come to this and we don't give much context or transparency on how we do this, right? It's kind of like magic. Okay, here's these citation statements, they're somehow classified as this. Like how is this working? And so, you know, I am currently actually working on a paper, and again, I can tell you it's not the most fun thing to do, all these, you know, writing of a paper that explains this and breaks it down. And I think, you know, there's double-edged side to that, because we are going to really say here, it's not so crazy how we've developed this. You know, it's really these simple things. It takes a lot of automated work, and that's great for trust. On the other side is like, oh, now someone could go off and do it. But I think that's important, right? Is if people are going to adopt something that is kind of new, they do want to understand it at least a little bit, especially if it's so crazy. And so I think that can be done, you know, by giving more transparency on the data. You don't have to give every single detail, because I think most people will be lost on that. But then I think really, is it solving something for me in a way that I understand? Is more important than, are you using Cybert or, you know, convolutional neural networks and all these fancy things. Yeah.
Right. So it's more about understanding. Sorry, go ahead, Niels, jump in.
No, I was just about to say, I mean, this is really a question that you asked. We could spend another hour or several hours, I think, on, because this is so important, but also so interesting. And I guess I usually take the example of autonomous driving as an example here. We accept somehow the fact that if we as humans drive cars, well, occasionally there are accidents and we take the responsibility then for it. But if we have an autonomous driving car and this car makes a mistake, and then we have a casualty somewhere and somebody dies in an accident, we have a difficulty in accepting that, because we then think it must not have happened. Although even if the number of errors that the machine makes is smaller or less likely than the number of mistakes than the humans make, still there is a difficult perception of these mistakes. And I think it's the same for this data. So we in academic publishing, we have learned for hundreds of years that there is somebody responsible for the content, and that's the author. And if even if it's not about better writer, even if it's about creating metadata or creating judgments on citations or creating judgments on the quality of language, or well, what happens if the machine makes a mistake, and is there a possibility of correcting it? And I think, for me, I would say normally I don't think it's a good idea to say there must be always a human controlling the machine in a very detailed way, because then otherwise the human could have done it in the first place, then maybe we are not saving anything. So we need somehow a robust environment. We need a possibility to say what are the critical errors. Where is ethically or technically or commercially something going wrong really seriously, and then we have to find a mechanism to correct that. But then the others, maybe we have to deal with it in a different way, and this is also I think a challenge for all of us to adapt here. And for me, I think the key element here is really transparency. I would very much like to see that every process step that was created with the help of artificial intelligence, no matter how you define it, should be labeled, and the people should know that it was that this kind of AI technology is or was included in the creation. And I agree to Josh. I mean, we don't need all the details of all the data in every situation, but we should know who was the creator of this service. Was it a human or was it a machine? And if so, just some basic underlying ideas. Who takes responsibility for it? And I think that is something that we have to define as an industry in a new way, because we didn't have this challenge in the past. I think that's something that we can only create somehow as a community of publishers rather than individually.
Yeah, definitely. One of the things that you sort of touched on, and you touched on in your presentation too, Niels, and something Mike talked about as well, is sort of if the machine sort of taking over a role. And one of the fears that has come, that is prevalent, in the world, is that machines will take over our jobs and we'll all be out of work. Do you see that? What do you see those people who are currently doing some of those jobs doing? Will they do something else? Will their jobs be eliminated? Will those, how will that be, the workforce be impacted, the human workforce be impacted by this? Mike?
So we often get this as a question, especially during production phases that do require vast networks of often freelance copy editors. And the standard answer is I have yet to see an AI application that completely 100% replaces human judgment. There's always some point, the legal review perhaps that Niels mentioned, somewhere where there are people intervening in order to sense check the system. And it's really about enabling publishers to focus on the science rather than on the process in this case, or in many cases. And so it's about empowering individuals to work more efficiently, say. So again, with the copy editing example, when you have the phased tracks, and you're freeing up resources where people whose first language is English don't, and then there are, say, papers that are coming in from Asia or from Latin America or the global South, and they're not all queuing up and backing up behind a human copy editor who really doesn't need to give that sort of individual level of attention to every single article. And so it's about dedicating the resources for copy editing in this case to those manuscripts and those authors that really need it the most, the human intervention. Mm-hmm. So it's about enabling publishers to work better, not displacing people.
Yeah. And do you think that, Niels, if we have a book that's written by beta writer and a book that's written by a human writer, will those be competitive? How will those two writers sort of battle against each other in that way?
That's a good question. They can be competitive in a way, but I really don't think neither with this example will make authors obsolete, nor with any other example in creating data or metadata or replacing processes, will not make a fully automated publishing workflow where no humans are involved. I think if you look at the specific service, you will see lots of examples where you needed X persons in the beginning, and then you automated it, and then you need fewer people in this process. I think that's very true, and I think we should not say this is not happening, this will happen, but it happened also in the past and will always be in the future. I think that's a very typical economic situation or technological change situation. But then on the other hand, I'm quite confident that, or if I observe the last 10, 15, 20 years of academic book publishing, there are so many tasks coming in addition to that we need to do. And I think we need to take care of more topics so fast that even if we reduce the number of people involved in other tasks, still the number of people involved in the whole process, at least for my company, has grown. So look at all these topics on publishing ethics and code of conduct and really making sure that all regulations are met and so on. This is a lot of work that did not take that much effort 20 years ago. It is now. So even if we automate some of it, we will still need more labor than before. So I'm always wondering, yes, what this effect that you described is somehow true, but only if you look at one specific a process step. If you look at the whole process, then the picture looks very different. And I mean, it also from a different perspective to the same question would be, I'm happy to make really very repetitive and boring things automated if then our staff can do more the creative and more intelligent things. So that's for me the driving factor. Yeah, let's try to really make it that all of our colleagues and all of the researchers can really concentrate on creating knowledge, making true judgments, being really a necessary process step in the whole process, and not doing something just pressing a button or checking whatever could be checked by a machine. I think that makes our job safe in the long run.
Yeah, no, definitely. Well, and one thing that we sort of talked about at a previous conversation was there are, depending on who's building the system, there is some unintended bias sometimes. And in the Unsilo survey, one of the things that came out was that only 10% of those tools address that bias. And I wondered if that was anything that people were working on, or if that was sort of maybe the future, a little bit of focus for AI development or for looking at tools and things like that.
Yeah, it's interesting that you mention it in this way, because we explained our algorithm, for example, in the beginning, that we are making bias-free summarizations. Because if you ask a person to summarize that topic, then there will be always a bias. Like there is you like or dislike a colleague, and then you will not cite him if you don't like him, or you belong to a school of thought, and you have these little cartels and so on. So there is always a human element in it. Now we are replacing this human element by an algorithm, but it's true. I completely agree. We don't know if we are replacing one bias by a different type of bias. That's even more difficult to identify. Because we cannot discuss it with the creator of the bias, because it's so implicit in. But again, I think maybe Josh, you know more about technologies here and what we can do to identify them. I mean, maybe we need also more mechanisms to really find, or to really in a data-driven way judge the quality of the outcome of our processes. I don't know. I think I don't have a full solution for it, but I think it's really worth taking care of the problem. I see it coming in a way, but
Yeah, I would say there isn't a full solution, right? And bias is here, right? And it's going to be there in the future. And I think, understanding it and trying to address it at each step of the way matters, right? So for example, when I showed how we annotate citation statements, it's literally just a text, right? We're not showing the authors, where this was published, these other things. And I think some people often say, oh, well, I mean, this could be biased. Maybe you're training just with these types of authors or these types of authors. And again,
Right.
we take steps to try to like minimize these things, because maybe if I saw this and it was in my field and I say, oh, I know that one's wrong for this reason, some of my bias would then be built kind of into the system and amplified. And I think that is going to happen. And so I think one thing that I kind of talk about is the AI is hard. It's a hard part for us to develop, but even more difficult or equal difficulty is kind of the user experience, right? How do they interact with that? And one is kind of, it's more systematic, it's easy. Here's this problem, here's how we approach this. And then here's this other one that deals with humans, which is also can be very systematic, but is difficult, right? Is how does someone understand this? How do they, first see this? What does it mean to them? And really taking care for all of those things. And so bias at, the training of the data or adding of the data to the model, to what words do you use to describe things? And so at Scite, we started with very strong words of confirming and refuting. And, we didn't think that was really accurate of how it reflected how we were scoring things. And so we've adapted things and we've learned from humans, and we'll continue to kind of learn and continue to try to make improvements. And so I think, communicating these biases and what the machine did and understanding these things better to a user in different ways is something that will help a lot. And one thing that I'm particularly excited about that we're going to work on soon is, we have this snippet, we have now kind of the numbers that come from the model, so you can see what is the model kind of quote unquote thinking, if you will. Soon we'll highlight the different keywords that really had the most influence there. And again, this is all so that the person can kind of understand and be comfortable, as opposed to, here's this magic, just trust us and it's good, we're not going to explain anything. And so I don't want to minimize it. I think it is something that is very important, but I think it's also something that like people see and like immediately they're worried, right? Whereas like there's huge bias already in the literature. Choosing not to cite something, for example, is a big thing, right? We've analyzed hundreds of millions of citations, and I can tell you the literature is very biased, right? Most of these are just mentioning there's such a rare, amount of disputing citations, because people, don't want to cite things negatively, because that's how they kind of punish in today's kind of system. Whereas, maybe if we can encourage more clear debate, we'll start to change some of these biases or minimize these things. And so I think that's the interesting thing. Negative work example too, maybe as a scientist, I did all this stuff, I don't want to write a paper now, but I have data, maybe beta writer can write my kind of negative findings. And so that would help solve this file drawer effect. And I think that would be great, right? And so you get the data, maybe it's not like Shakespearean writing, or maybe it even is, because beta writer is going to be able to write better than me soon. And we have all these things that are not, even published. And so I think there's just so many opportunities of where this can go, and we are very early on. And so I think as we solve kind of these more basic problems, it's going to be really exciting to see where some of these more creative things come.
Yeah, definitely.
Aaron, if I could just add.
Yeah, please.
Just to close out on the bias topic. So another way it often comes up as a concern that AI, introducing it into the system, is creating a whole new nefarious opportunity to create new kinds of bias. And Josh pretty much explained, the systems of the corpus of literature may already be infused with some sort of institutional bias, but you could even say that the AI helps suss that out even in a better way. So we've learned from examples in other industries where married couples who have the same income, the wife is approved for a less amount for a loan than the husband, or in healthcare disparities, the costs assumed for certain racial minorities is less just based on historic spending than it would be for say a family on a plan that is a white family. And so it just highlights kind of in an embarrassing, shocking way that the assumptions were wrong all along. And when a machine comes back with that result, then it's questioned more. So and just and finally, there are different phases of the publishing process where there are less critical high stakes decisions about people and processes. If we're just analyzing sentence structure, say, or if we're just trying to surface content in order to create a new collection, it's not 100% foolproof in a bias sense, but it's much lower stakes and there's mostly upside.
Sure. Yeah. Well, we have time for just one last statement from everybody. So, Mike, do you want to kick us off on final statements on how important AI is?
Yeah, I mean, I think that it is an opportunity for publishers to speed up processes. As we've covered at length, there are many manual and repetitive processes that don't need human judgment, that could easily be applied to speed up the process and serve society in a much more effective way.
Yeah, I mean, I would echo upon that. I think, you know, AI is kind of really given a lot of people superpowers in different ways, right? You can do things that you otherwise couldn't. Maybe they're the nerdiest superpowers that you can think of, and they're not flying, but they really are, right? You are synthesizing, understanding things that you just otherwise couldn't. And so if you look at it from that perspective, I mean, here's this great opportunity for me to better understand, you know, these things that directly impact how I, you know, develop a cancer therapeutic, or how I stand when I give a talk, or policies for the government. And so I think, you know, I'm not this AI is good blanket rule, because I think there's clearly some, you know, bad cases, but I think there's also some really exciting things to come from this, and so obviously, you know, I'm hopeful for the future of this.
Good. Niels?
Yeah, I fully agree to Mike and you, Josh. I think it's really important. It will be more important. Not every application will be useful. We have to think about controlling it and making it accountable. But I think it will be almost as important as real intelligence.
Perfect. Well, thank all of you. Thank you, Mike, Josh, Niels. Thank you to SSP for having us. And I hope this was useful to all who are watching. Thank you so much.
Thank you. Bye-bye.
Bye.
Thank you.